Greetings, my name is KC Santosh. I'm the chair of the Department of Computer Science as well as the founder and director of the Applied AI Research Lab at the University of South Dakota, which is the flagship state university. In this talk, I'll be looking at the following items. Number one, what is cross-population train and test model? Number two, challenges, opportunities, and risk. Number three, experimental results, very quick, on the use case COVID-19. Number four, future epidemics. In this slide, we'll be looking at what is cross-population train and test models with examples. It is a machine learning or statistical technique where you can train a model on data from one population or group and the test or apply that model to a different or separate population or group. For example, if you are looking at developing a medical diagnostic tool or model, you might train the model using data from one hospital or geographic location. In this slide, we're taking China for example, and then test its performance on data from different hospital or location. And in this case, we take Italy as an example. This is done to evaluate how well the model generalizes to new unseen data from different populations. Remember, the test samples coming from Italian population were never been trained. I repeat, the test samples coming from Italian population were never been trained. The purpose of this approach is to assess the model's robustness as well as generalizability. It helps determine whether the model's performance is consistent across different populations or if it is overfitting to the specific characteristics of the training data. If a model performs well on both the training population and the testing population, it suggests that the model has a good generalization capability and is less likely to be biased or limited to a specific group. Therefore, I repeat, cross-population training and testing can be particularly important in those fields like healthcare, where models need to work effectively for a diverse patient populations or groups. In this slide, let's talk about challenges, opportunities, and the risk associated with cross-population train and test models. Building cross-population train test model can introduce several risk, challenges, as well as opportunities. Number one is data distribution differences. What does it mean, right? Different populations may have different data distributions, which can lead to data shift. In this case, a model may struggle to get generalized. It also brings data quality and availability into account. Training on low-quality data may produce poor performance. However, if it is well done, it is a win. Let's talk about overfitting risk. When the model is too complex, it may overfit the training population, which can make it less adaptable to new populations. Remember, we talk about adaptability in here. Overfit models can perform poorly on unseen data. In machine learning lingo, fairness term is very important. let us talk a little more about fairness. The process of correcting and eliminating algorithmic bias from machine learning models is we call improved fairness. How to do that? They typically come from their race, ethnicity, gender, sexual orientation, disability, and class. If we include all of them, then it is a win. Adaptability in cross-population models are more versatile when it comes to adaptability and can be applied across various contexts, making them suitable for broader use cases. Another beautiful term in machine learning lingo is transfer learning. Training on one population and testing on others can leverage the knowledge gained in one domain to improve performance in another. This is what the beautiful opportunity coming from cross-population train and test models thing. In this slide, let me talk about tuberculosis dataset. And the dataset we're talking about is chest X-rays. In our study, we aim at providing an idea of how well a model can be trained or tested on different datasets. So we consider 3 different datasets from different locations. Number 1, Shenzhen Hospital, China. 2, Montgomery County, USA, and Indian Hospitals, India. To be specific, our work is aimed at analyzing or screening tuberculosis from chest X-rays. Let's just get into the experimental results. Using handcrafted features on conventional machine learning models, we have received silver lining performance in the first run. What does it mean is cross-population train and test models work as expected. Look at the arrow in the slide. Let us dig a little more. When Montgomery County, USA, and China Hospital datasets were used for training, we have received the maximum area under the curve of 96%. Hooray, right? Silver lining performance, right? What have we learned so far? We have learned that handcrafted features may not work for diverse group of populations, and it is primarily due to the change in demography. How about this? To be able to include distinguishable features from multiple different possible groups of populations, we let deep learning models work on such case. That means no to feature engineering. And using the lightweight possible pre-trained InceptionNet model, we call him truncated InceptionNet B3 model, we have received the maximum area under the curve of 84%, where the model was trained on large population, that is Chinese data collection, which is almost 5 times bigger in size as opposed to Montgomery County, USA. Let's talk about COVID-19 and the need. It is a time for us to ask whether we have had cross-population train test models in place for COVID-19, or have we had such models specifically for medical imaging informatics. Back in March 2020, I have come up with the research paper titled AI-driven tools for coronavirus outbreak, where 3 terms are employed. Number 1, active learning. 2nd, cross-population train and test model. 3rd, multimodal and multitudinal data. In other words, it is multimodal learning and representation. And that's what we should be doing, right? Important note, such studies are essential in the development of medical imaging informatics solutions to ensure that the models are not limited to specific patient groups and to enhance their practicality, accuracy, and fairness in healthcare applications. Once more, in reality, COVID-19 as an example, can we not train our model with or without feature engineering on Chinese data collection, and the test on the data from Italian collection. Yes, it is possible. Then what made us stop doing this? As before, I repeat, our machine learning models can be generalized. It can offer the luxury of transfer learning and many more, even within the context of cross-population train and test models. If that's the case, isn't it a time for us to look in such a way we save lives rather than waiting data from Italy, for instance? I repeat, the data collected from Chinese hospitals could potentially be enough for us to train with all possible clinical manifestations due to COVID-19, right? Therefore, as a machine learning scientist, here is what I had to say or state. If we had built or access to cross-population train test models, we might have been able to save thousands of lives during the 2020 and 2021 COVID-19 pandemic. In other words, for all possible future epidemics, there is always a possibility to have cross-population train test models in place. I definitely have to thank you for watching me, and I'll see you with more content in the future.